I'm Alonso Gonzalez. I'm come from Mexico City, and the project that I choose to work on is related to hydrology. In this case, is the extraction of river streams using BIM datasets downloaded from the US Geological Service and also GRASS. I'm going to start by introducing a little bit about the software that I use and some of the decisions that this came with. So basically, GRASS has been existing since the 80s. It's one of the founding members of OSGeo. And for me, it had three advantages for using it. The first one is that you can use it inside of QGIS. The second one is that it can be used as its own user interface. And the last one is that it can run parallelly in the command line for the GRASS syntax and also the bash syntax. So this allows you to have a lot of flexibility when working with different backgrounds. And for me, it's one of the main keys in what I do. The tool that I choose to use is the extension. GRASS has over 350 extensions. RStream is one of them. And it comes from theory back in the 90s, where it says that all of the streams can be simplified by using a center point and 8 vectors in which water can flow. And the logic behind it is that the steeper slope will have the flowing of the river. So this was a very bright idea back in the 90s because either the prediction were too vague or were too straight, and neither of them fit the case. In this project, I choose some of the work done by Giuseppe that is uploaded into spatial ecology. So I combined that code with another resource I found online, and we took all of the extent of Latin America. We downloaded the DEM and divided it into 3 areas. This was done in order to have a better performance of the machine and not overloaded. So I basically use 5 functions. Have you heard of any about this, or is there any question up till this point? No? Okay. So the first section of my code was bringing in the variables that I needed to use. In this case, the first one was the DEM, and it will give us the elevation. The second one, it's going to be OGR info, and also awk running the grep variable. So in this case, we have the 3 main shape files. For example, the north will have a east limit, west limit, south, and north. We will grab that information and store it inside of a variable. With that variable and our DEM, we're gonna crop the areas using the things that we kept in the memory. In this point, we are ready to run the RStream extract, which is done in GRASS. And this is one of the main challenges that I found in the project. I will explain it a little bit more. And lastly, I use raster merge in order to bring it all together and recreate the image we had in the beginning, but with the stream attached. And lastly, I would like to point to you some of the things that I found throughout these three months of the process. And the main challenges that I personally encountered were setting up the environments, first for the virtual machine, and then for the environment in GRASS. And this also gave me insights, which are really valuable for me. And it's like, when you're trying to make something work, there is a lot of documentation online. So you can just go online, search, and read the manuals, which are a basic ability that you need to develop. The second one is understand this syntax, which for me is kind of organizing all of the processes that I wanted to do and pinning down the procedures and being really logical about them. The last couple of steps, I think it's about selecting a case and understanding what is possible to do with a tool. So you can have like a ton of tools, but if you don't know what it's doing or what are the inputs that you need to put into the machine, you're not gonna get anywhere. So that for me were the biggest challenge and also like the big payout that I had with this project. So I'm gonna show you the code and we can. Okay, so we are running on Grass 7.0. The first thing that I needed to do was go from Grass 7.6 into 7.0. And that took me like a whole day to find out where the resource was or what was happening. And Xiaomin, we worked together that part and we were able to run it. The second thing that I do is with GeoPandas, we bring the shape files. So GeoPandas was the surface that helped me manage the shape files, the 3 shape files that I show you. So in line 6, we are ready to run the analysis. As I was telling you, Grass allows you to run parallelly between Bash and also the Grass environment. So for me, that was a big help because I was able to communicate with Grass using the things that I learned and the things that I was most familiar with as code. So during these first lines, I'm bringing the DEMs and all of the information that I need. With these 4 lines, I'm grabbing the extents that we need to have. And this last line will run the process to do the work of the streams. Lastly, these are some of the results that it gives. This is the environment. And with Rasterio, I bring them all together and created a list that will sort all of the tiles that I need to put together. And these couple of lines will merge them together. And here are some of the results. As you can see, the area is really big. And you cannot distinguish anything like in this picture. So you need to zoom in into an area and just print a window. Even in here is a little hard to see it. On the top, you can see like the line, like a yellow line with green. So that's a river. And one of the things that I was seeing yesterday is that the Amazonian River is just like really intense green. And that gives me a sense of how much vectors are running into that single line. And those are interesting things to see and to be able to observe. So I think that's about it. Thank you very much.
I have one question, but what do you see over here as you get several output from the R models, R string models, and in particular this one. What is this one?
It's the line of the rivers.
No.
No?
No.
It's the raster.
Is there anyone can say something about? Show me you. Yeah.
I believe this is the amount of pixels that are above each single pixel.
Perfect. Perfect. So this one is the flow accumulation from where you derive the stream network later on. Okay. So each single pixel is taking into account the upper stream. So they also call flow accumulation area. Okay. So be careful about this one, in particular for people that are going to deal with grass. Okay, first of all, Alonso, very good, because I didn't explain grass. So, but I point where are the sources. So means that the video that I did 2 years ago are still useful to have it. And of course, there is some adjustment that need to be done in according to the version. Of course, some paths were different from actually 3 years ago. Pay attention about if you are working for the flow accumulation. So this is the typical cases that is not very easy or possible parallelize. In particular, the flow accumulation in grass has a limitation of number of cells that cannot be larger. Where is the no, it's in here. That cannot be larger of a particular amount of cell. And this cell, where it's coming from, is the maximum value of int unsigned int 32. Okay, so that number of cell cannot be overpassing, because probably when they code it in such a way that you need to have the matrix. The flow accumulation really you cannot do it at pixel level, because when you work over here in the Amazon, you need to know what is going over here. You need to count down. That's why it's always so big and so complex to work. So this is coming from my work. And so I divide in tiles, and I was sure that in this case, the full Amazon was already inside, okay? So this is, for example, a limitation that we are going to face in our group when we want to go at 30 meters. This has been done 90-meter resolution when we want to go at 30-meter resolution, because the Amazon, Mississippi, and Nilo already reached the capacity of the unsigned int 32. So we need to talk with the developer to probably switch to float 64 in order to be able to enlarge the to enlarge the study area. In this case, everything goes to the memory, okay? And the memory is not a big requirement because it's 70 gig of RAM memory. So with supercomputer, you can do easily. It's not 1 tera or whatever, but you have the limitation inside of the code for the size. So this parallelization can be done in tiles, because each tiles can go to a CPU, but cannot be done inside to the tiles at pixel level. So this is quite often happen in geographical information science when you work with a spatial related stuff. So you are not on the phenomena that is happening here is only also due to something that is happening far away, especially for the water that is running it out. Okay, very good that you summarize all the different challenging also that you combined. Alonso was coming in my class in Yale like 3 years ago, and I see a big improvement from now to 3 years. So really, appreciate. Good that you also use, for example, Rasterio that I was not explaining, but there are resources, so probably you find it. So here you don't see anything because the pixel with high value, this is a skew. This is skew to the left. You have many pixels with low value and just few with high value. And then of course, when you do an image very small, you don't see. Okay. Anyone has some question in this regard? Probably maybe somebody that was working also with grass and so on. To Alonso, Giske, or Chomi.
I guess I have some of the same problems with grass. It's also difficult to find out, but I really like the way you use the automatic cropping. That's something I want to implement later on, so I will just get your code.
Yeah, perfect. So for the other here, we have grass is quite rigid in the map set and location map set. And you can follow this one as an introduction. Please follow the introduction. Don't start grass immediately, because if you don't get it how it works, then you cannot communicate. You cannot really work in grass. So this one together with the video that is somewhere here in the web seminar over here, introduction to grass. This video over here is linked with the material that is here, grass introduction. And then of course there are some differences, as I mentioned, due to the version. And then this one is a bit an application on stream network. Okay, very good. Yeah, you summarize very well.